Dear children, we have already studied about hybridization and hybridization in ethane and ethene. Hybridization means intermixing of the orbitals which are slightly different in energy and shape to give a new set of orbitals known as hybrid orbitals which are identical in energy and identical in shape. Today we will study about hybridization in ethyne. Ethyne, the molecular formula is C2H2. We know that carbon is tetravalent, and in this case, since there are 2 hydrogens and 2 carbons, it means in addition to the sigma bond, there must be a pi bond. In ethyne, there are 2 pi bonds and 1 sigma bond between the 2 carbon atoms. Let's discuss hybridization in ethyne. sp hybridization in ethyne or sp hybridization of carbon atom. Carbon, atomic number 6, electronic configuration 1s2, 2s2, 2p2. It is the ground state electronic configuration. Now in the ground state, there are only 2 unpaired electrons. Now these 2 unpaired electrons cannot make bond with the 2 carbons and the hydrogens. So the electron from the 2s orbital will get excited to the vacant 2p orbital. Let's see. Ground state, 2 electrons in the 2s orbital and 2 electrons in the 2p orbital. Promotion of electron. 1 electron from the 2s orbital is excited, is promoted to the 2p orbital which was vacant in the ground state. Now, sp hybridized state. 1s and 1p orbital will undergo hybridization, and this is sp hybridization. It will have 50% s character and 50% p character, and there will be 2p orbitals, that is 2py and 2pz will remain unhybridized. This mixing of the orbital of s and p orbital will take place in both the carbons, and now both these carbons will have 2 sp hybridized orbitals each and 2 2p unhybridized orbitals on each carbon atom. Now let me show you and explain this through an atomic model kit. This black ball is one carbon and this is another carbon. These are the 2 carbons of ethyne. Now these 2 carbons are sp hybridized state. Now one sp orbital of this carbon will get overlapped with the sp orbital of another carbon, and sp hybridized orbital of one carbon will make bond with the 1s orbital of the hydrogen atom. The same thing happen with this carbon also. The sp hybridized orbital of this carbon will make a sigma bond with this 1s orbital of hydrogen. Now you can see that these are linearly oriented and the angle is here 180 degrees. It is linear in shape. Now in this molecular orbital kit, you can see that the 2 carbons and the 2 hydrogens are linearly arranged, and these are the unhybridized p orbitals. These are the lobes of the unhybridized p orbital, and it is on both the carbons. They are unhybridized. Now these unhybridized p orbitals will undergo sideways overlapping, and we know that when there is a sideways overlapping, a pi bond is formed. Let me show you again through the bent pipes. Now I am showing you the overlapping of the p orbital, and this overlapping is sideways, and whenever there is a sideways overlapping, the pi bond is formed and the restricted rotation is there. A bond cannot rotate through a pi bond. It will break. Now you can see this. The pi orbital which were oriented along this direction, the upper lobes, just imagine these are the lobes. Just compare the two structures. They are actually same, but in this structure I am showing the p orbital in the lobes form, in the dumbbells form, and there is no overlapping. But actually they are overlapped, and this overlapping I am showing you through this. You can see the overlapping. The p orbitals which were oriented along these directions, the upper lobes, they overlap and they form the electron cloud above this plane, and the lower lobes, they overlap and they form the electron cloud below this plane. And similarly this p orbital, these orbitals, they overlap here and in this direction. Now you can see that this is the overlapping of the p orbitals. From the pictures also, let me clear this explanation and this phenomena. In figure A, you can see the sp hybridized orbital of each carbon overlapping with the other carbon and 1s orbital of the hydrogen. Figure A is just showing you the initial linear shape of this molecule and the angle of 180 degrees. Figure B is showing you the sideways overlapping of the p orbitals. The py orbital overlaps with the py orbital because of the same parallel orientation, and the pz orbital overlaps with the pz orbital again due to the same reason, same orientation. Py orbital cannot overlap with the pz orbital. In figure C, you can see the electron clouds, the pi electron clouds above and below the plane and surrounding the sigma bond. The unhybridized 2py orbital of the first carbon atom undergoes sideways overlapping with the 2py orbital of the second carbon atom, and a pi bond is formed between the two carbon atoms. Similarly, the unhybridized 2pz orbital overlaps sideways, forming another pi bond between the two carbon atoms. All the carbon and hydrogen atoms are linear, and there is an electron cloud above and below, in front and at the back of the carbon-carbon axis. From the diagram also, it is very clear that there is a sigma bond between the two carbon atoms, and also there are two pi bonds between the two carbon atoms. And each carbon atom is bonded to one hydrogen atom each through a sigma bond. Sideways overlapping is very much clear from the figure. This is the three-dimensional view of Ethyne. You can compare this with the model I have shown you earlier. Let me show you it again. This is the atomic model of the Ethyne. You can compare it which is shown in the picture, that is the three-dimensional view of Ethyne. Again, this is another form of Ethyne. Just now I explained you the phenomena of hybridization in case of Ethyne. In Ethyne, the hybridization is sp. The shape of the molecule is linear and the angle is 180 degrees. In Ethyne, between the two carbon atoms, there is one sigma bond and the two pi bonds. There is one more sigma bond between the carbon and the hydrogen. There is restricted rotation about the two pi bonds which are formed by the sideways overlapping of the 2py and the 2pz orbital. I am sure that hybridization in case of ethyne is clear to you.